Four objects of various masses, each denote m, all have the same radius. They are all rolling at the same speed as they approach a curved incline as shown below. Rank the objects based on the maximum height they reach along the curved incline. So we have to rank the objects. The objects are hollow sphere, solid cylinder, hoop, solid sphere. And then each has a different mass. And then we have to find out which one will reach the maximum height. Okay. To find out this one, we have to use the energy considerations. Okay. Here, all the objects have rotational kinetic energy and the translational kinetic energy, because all the objects are sphere. One is sphere, hollow sphere, and another one is a solid cylinder that also rolls. Okay, sphere rolls, and then cylinder also rolls, hoop also rolls, and the other one is solid sphere. So all the four objects will roll. That means they have the rotational kinetic energy and also translational kinetic energy. So when we equate them, then what happens here? Let us see. E initial is equal to E final. Am I right? So energy is conserved. So total energy of the system remains constant. So initial energy is equal to final energy. What is the initial energy? Rotational kinetic energy plus translational kinetic energy. So rotational kinetic energy is equal to half I omega square, and translational kinetic energy is equal to half mv square. And the final energy is gravitational potential energy, which is mgh. And here, for each object, we have to find out the rotational inertia or moment of inertia. And moment of inertia of the hollow sphere is 2/3 mr square, and moment of inertia of solid cylinder is half mr square, and then moment of inertia of hoop is mr square, and moment of inertia of solid sphere is 2/5 mr square. Now, once we know these values, now we have to plug in these values in this equation, and then we have to find out. So EI is equal to EF, and then half I omega square plus half mv square is equal to mgh. So plug in each case, and then moreover here we have one more thing. Omega is equal to V by R. Therefore, omega square is equal to V square over R square. That we have to input here instead of omega. So first one is hollow sphere. So you put the hollow sphere. So half 2/3 mr square times V square over R square plus half mv square is equal to mgh. On simplifying, we will get h is equal to 0.83 V square over G. Okay. Next to hoop. For hoop, again, plug in the values. Here, hoop mr square. So first, this is half is the half I omega square. In that, if you put half, instead of I, put mr square, and then instead of omega square, write down V square over R square plus translation kinetic energy half mv square. So H is equal to V square over G. Next, go for the solid sphere. Solid sphere again. Here I is equal to 2/5 mr square, and then we have to put half I omega square. No, rotational kinetic energy. So half 2/5 mr square times V square over R square plus half mv square is equal to mgh. On simplification, we get 0.7 V square over G is equal to h. Then finally, we have to calculate the solid cylinder. Now, for solid cylinder, I is equal to half mr square. So we have to substitute half I omega square. No, so half times half mr square times V square over R square plus half mv square is equal to mgh. Okay, so h is equal to 0.75 V square over G. Now, tabulate all the values. H hoop is equal to V square over G. H hollow sphere is equal to 0.83 times V square over G. And solid cylinder is 0.75 V square over G. And then solid sphere is 0.7 times V square over G. So this is the order. Let us see. H hoop here goes highest level, and then followed by the solid sphere, hollow sphere, and then solid cylinder, and then solid sphere. This is the order. This goes the highest, largest value. Here you see this one. So rank from largest to smallest. Rank the objects based on maximum height they reach along the curved incline. So hoop reaches the maximum height. Am I right? See here. Hoop has v square over g, then followed by hollow sphere, and then followed by solid cylinder, and then finally solid sphere. Understood? This is based on the energy, conservation of energy. And then here we have to consider the rotational kinetic energy and translational kinetic energy. And then the total energy is equal to gravitational potential energy. Hope this helps. Thank you. Bye bye.